So now we've got that. What we're wanting to do is find the coordinates of point G such that the area of the rectangle is maximized. So we can draw the rectangle in a number of ways. Like another way is to draw it from here to here and then across. Is that bigger than the other one? We don't know. So the very first step here is to find the equation of the area. So the area, right? Uh, the area is equal to our width, okay, our width, and then also multiplied by our height. Okay, so the height, all right, is just going to be the y value that we choose. Okay, so that is the y value. Now the width is going to be the difference of 8 minus by that value of x that we've chosen. So it's like 8 minus by that value of x. So hopefully that makes sense. I'm just going to explain that a little bit more. If we choose a point here, and our axis starts here, and this we always know is 8 units. Okay, that's the whole point. What we're going to say is that the width is from here to here, right? From here to here, but we only know the value from here to here, which we're going to say is x. Now it's a bit confusing. Let's say it's the number 2. All right, let's say it's equal to 2. All right, well then the width should be 6, right? So how do we get that? We said 6 is equal to 8 minus 2. But let's take the number out and then let's put in just that variable. There we go. Now, we need one variable to use and we can't use the y. So right now, what we've said is that our area, our A for area, is equal to 8 minus by x and y times by y. But we can't use that. You can't, there's two variables in there. Luckily, we have an equation where we can say sub y is equal to the square root of x, because that's given. So now we can say 8 minus by x multiplied by the square root of x. Perfect. This gives us an equation that we can optimize for. All right. So there's two ways to do this. You can either graph it. It doesn't, because it doesn't tell you in this question, right? It doesn't tell you how to do it. So there's two methods. I'm going to do it using the graphing method, which is the easiest to get to the final answer. But it's 5 marks, so I'm pretty sure they want you to use some calculus. So let's go to graph and table. Let's plot in our values here, and let's go, that's x, and let's plot in, and we can zoom out. Cool, so then we can find the maximum. We go now, analysis G solve max, and that's our maximum there. So we can say for method 1, which is probably not going to get you the most amount of marks, but it's just a good idea to check yourself. So graphing method. Okay, so you've got to graph it, right? And all right, there you go. You say G solve max, and then you can say y is going to be our area in this case. So we've got the y value there and the x value there. And so you can say y is equal to 8.7. Oh, so A for area is equal to 8.7 units squared. Okay. And what we're trying to find is the coordinates of G. So our area is 8.7 units squared. That's not as important, but what we can do here is say that our value of x is equal to 2.66 recurring. That's the x coordinate of it. and then the y coordinate is equal to the square root of that. Okay, so then we can substitute that point in. All right, and then let's do that. Let's go to main, keyboard, substitute in 2.666 forever, and that's equal to 1.63. So coordinates, 2.6 recurring, and 1.63. And we could just let the marker know that we've rounded to 3 significant figures. Okay, and then that's one method of doing it. The other way is just to use the max function. Okay, and again, this doesn't really show you how to use it during calculus. It's a 5-mark question, so you'd expect there to be like a lot more guts to it, but we've already gotten 2 marks by finding our area equation. So that's really important. So the next bit here, is that you can just put in the equation that you want to maximize, right? Straight into here and go interactive, calculation, and Fmax. Okay, and then you can have like the mins and max limits there. We don't want to go anywhere past 0. So the max value occurs at 8.7, right? The same as before, and then 2.6. So now we can then, it might be easier just to grab that value there and put it straight in. Oh, grab the value of x and put it straight in, and then we can find our value of y straight away. Okay, so that's the other method that you can use, the fmin and max function. But the hardcore way would be to say that the area, so we'll just make this the second method. So calculus method. Calculus method. All right, and what we say is when a, the derivative a of x is equal to 0, turning point, so TP occurs. Solve for x using calc. Okay, and so what we can say here is use our calculator. So this, I'll just grab it from up above, this equation here, and I can go calculation, diff, I can find the derivative at the value of x is equal to 0. Oh, sorry. I just need to go interactive, calculation, diff. Okay, and that gives me that. I'm just going to put it into standard to make life a little bit easier. So this guy here is equal to all divided by 2 square root of x is equal to 0. X equals, right, grab all of this, put it down here, equals to 0. Go interactive, advanced, solve. X is equal to 8 divided by 3. And then you can check it's a maximum using the calculator. By the graphing, or using the second derivative test, but I don't think we need to do that because we've got a calculator here. Okay, and we can just draw it out. Perfect. Now we substitute it back in and then we get our final answer. So hopefully that explains how to use the calculator quite well in a couple of varieties, in a couple of methods to find your maximum area. So really lean on the calculator here, otherwise you'll be doing a lot of work by hand and there's no point doing that. You don't have to do the second derivative test here, especially when you get the calculator. It's only a 5-mark question. So hopefully that helps. There's plenty more exam questions like this on my website. If you need extra help, reach out. We offer tutoring as well. But there's heaps of examples of exam level questions that you're gonna get. And so if you do them all, you're likely to get really high marks in your exam.